Which of the following is the strongest acid? And so we have 4 structures to compare, and we should notice that these all contain these same functional groups. What we have is a series of 4 carboxylic acids. And so we have some trends for determining acidity that we can look at. So the general acronym that we've been using is CARDIO, C-A-R-D-I-O. And so C is charge, A is atom, R is resonance, Di is dipole induction, and O is orbital. And so C, charge, that if we had one of these that had a positive charge on the carboxylic acid, if it was protonated, then that would be the strongest acid. A is to compare the atom that your acidic hydrogen is attached to. And in all of these, it is the same. In every case, you have a hydrogen attached to oxygen. And then R is resonance. But these are all carboxylic acids, the same functional group. So they all have resonance, which is this resonance of the conjugate base. So the resonance tells us that these electron pairs, this extra lone pair of electrons, can be shared because we can move where we have the double bond and we have the single bond. And so this means that those 2 oxygens are actually sharing the negative charge, which stabilizes it. So it's more acidic than just an alcohol. But these are all carboxylic acids. So we've been using this as our hierarchy. We started up here because if one of these was protonated and had a positive charge, then it would be the strongest acid, but we don't have that. So we moved on to atom. Well, they're all attached to oxygen. Okay, well, maybe there's a difference in resonance, and there is not because these are all carboxylic acids. They all display the same resonance. So now we move down to dipole induction. So what this means is if you have a substituent, something in your molecule that can also help to share the charge, to pull electron density away from that carboxylic acid group, that is going to increase acidity. So this is looking for electronegative substituents. And these can increase acidity. And it depends on what that electronegative substituent is and its proximity to the acidic hydrogen. And so if we look at these are all structurally similar. So C is your unsubstituted carboxylic acid. And these others have halogens. That means actually that C is the weakest acid. And so the strongest acid is going to have the most electronegative substituents. We're looking for the more electronegative substituent. So we've got chlorine, we've got fluorine, and we've got bromine. And fluorine is the most electronegative. So that means that this is the strongest acid. We do not consider the size of the halogens because we only consider size if the negative charge is actually going to be on that atom. So a larger atom can better stabilize a negative charge, but there's no way to put the negative charge on the halogen, so we don't consider that. We just go purely by electronegativity, and fluorine is the most electronegative.